Hello everyone, myself Hashni. Today I am here to explain a Python code which is used to implement the algorithm of QR decomposition using Gram Schmidt method. The function is implementing QR decomposition using Gram Schmidt orthogonalized method. Firstly, import numpy as np, which is used for arrays, vector operations, and linear algebra. The function QR decomposition definition takes a matrix of A and next n comma n. Here n describes the number of rows and m describes the number of columns. The next two steps which creates two empty matrices q and u of size n into n matrix. Here u will store intermediate orthogonalized vectors and q will store the final orthogonal basic vectors. Next, take the first column of A as it is U composition. Normalize it like divide by its length to make the first column of Q. This means the first column of Q is just the unit vector in the direction of the first column of A. Next, the 5 steps are for the iteration. To iterate each value in the row for I, this is the Gram Schmidt process. Loop through each column I through A. The code initializes the corresponding column with U. Start with U composition is equals to A. For each previous column j, for I in range, the code subtract the projection of A onto Q. A at the right into Q is equals to projection of A on Q. Subtracting this removes the component in that direction. Next, after subtracting all projections, we get a vector orthogonal to the previous ones. Normalize it like divide by length to store the value of q in decompositions. At the end of this loop, u is equals to orthogonalized vectors and q is equals to orthogonal basis, which is the combination of orthogonal plus unit length. Next, we are inputting r is equals to np dot zeros. Creates an R matrix filled with zeros, computes the upper triangular matrix R. Entry R is equals to dot product of A with Q. This ensures A is equals to Q into R. Next, we iterate it. R of I comma j is equals to A into R. Print the matrix of Q and R. Takes matrix input from the user. Calls the function to perform the QR decomposition. This is the Python code to implement the QR decomposition, and we can see the